All right, more factoring, more videos here. Third and final video for the review, prerequisite skills, I guess it's called. And let's change that to blue. So now we're in blue. Let's go green. Green, you can see a little better. So what I was saying is when you have a simple trinomial, that means three terms. And the first term is x squared, second term is x, and third term is a constant. And this is where a is 1. So what we have is we start with an x squared, not 5x squared, 9x squared, or whatever. Okay. So you've done this a few times. What you do is you find numbers that multiply to this and add to this. I like to keep track of the signs personally. So what I do is I look at the trinomial and I say so let's go back and erase this so we can see this clearly. If these are both positive numbers, then we're going to know definitely that you're going to multiply and then add. You're going to multiply to a positive and add to a positive number. Then everything's positive. So that's really easy. So when you see a positive number and a positive number, let me clean this up too. What you know in the bracket is you have both positive numbers. So you want two numbers to multiply, in this case 2 plus 12. And so if you see a positive and a positive, in the bracket you have a positive and a positive. Okay. And so positive and positive, positive, positive equals positive and positive. Two numbers are multiplied to 12 and add 2 7. So what you can do is go through the factors of 12, 1 and 12, and say, does that add to 7? Nope, adds to 13. 2 and 6, does that add to 7? Nope, adds to 8. And 3 and 4 multiply to 12, and they add to 7. We're good. So you put plus 3 plus 4. Order doesn't matter. It never matters. The only thing is that you need the sign to go with the number. In this case, because they're both positive, it doesn't matter. Here, we have two numbers that multiply to a positive 18 and add to a negative 11. So if they multiply to the positive, the signs have to be the same, okay? But since this is negative, so when you have a negative and a positive, you know that both numbers are in fact negative because two negatives multiply to a positive, and when you add them, you get into a negative. So in this case here, you can kind of ignore the sign. So what I do is I always write x minus, and now you can ignore the sign and say what two numbers add to 11 and multiply to 18. So factors of 18 are 1 and 18. Those don't add to 11. 2 and 9, yep, they do. They add to 11. So now it's minus 2 and minus 9. Now you could put the negatives here. Okay, some people like to do that. But I don't bother because I already have them here. I have them built into the answer. So if it's a negative and a positive, it's negative and a negative and a negative. So the other two situations are if you have a plus and a minus. So if you have a plus and a minus, you're going to have a plus and a minus. So here I have two numbers that multiply to negative 20 and add to plus 8. And I want to do this at the same time as I do this question here. So here I also have a minus and a minus. So two numbers that multiply to a negative and add to a negative. This is two numbers that multiply to negative and add to a positive. So in this case, you have one of each sign each time. And the reason that is because when you multiply a plus and a minus, you're going to get a negative. So this is what they multiply to. They multiply to negative 20. They multiply to negative 44. So they have to be different signs. So you have a plus and a minus. The difference is this is a plus and this is a minus. And when you add them together, you know that if you're going to get a positive number, that the bigger of the two factors, okay, the 10 and the negative 2 in this case, okay, the bigger of the two is going to be positive because they add to a plus. So if you have two numbers that are one of plus and one's a minus, if you have a big plus and a small minus, then you're going to end up with a plus. So if it's plus 10 and minus 2, you're going to get plus 8. That's why you know, in this case, it's plus 10 and minus 2, not the other way around, because they add to plus 8. So a plus and a minus gets you a plus and a minus, and the bigger is the plus. Here, you have a minus and a minus. You still have a plus and a minus, but the bigger will be a negative because they add to a negative number, okay? So what you do is let's go back to get these numbers now, the 10 and the 2, I kind of whipped through that. You want two numbers to multiply to 20, okay? So let's say 1 and 20. And you can right now know that the plus is bigger, the bigger number, because this is positive. So these add up to 19, so not 8. These add up to 8, so I'm good, okay? So I want two numbers that add up to 8 or 8 apart, and the bigger is the positive. So plus 10 and minus 2. Here, I got 44, and I have minus 44 minus 20. I'm going to have a minus and a plus. So you can write it like this. So the bigger of the two goes first. Okay. If you don't, you can just write x plus and x minus. That's what I usually do. And what I do is x plus and x minus, and the bigger is the negative. You can write the negative first if you want. I don't usually. And what I know is the bigger is the negative, and so two numbers are multiplied to negative 44 and add to negative 20. So the bigger is the negative. So if I go 1 and 44, those are two numbers that multiply to negative 44. The negative has to be here because the negative is the bigger number. Okay, and those don't add up to negative 20. 2 and negative 22, those add up to negative 20. So that's my answer. So this goes here and that goes here, or like this. So like I said, it doesn't matter the order as long as the sign goes with the number. So this is plus 2, and that's plus 2. That's minus 22 and minus 22. These ones here I don't really care too much for. But if you do these, just ignore this. What you do is ignore the y, and then just go through this and say to yourself, two numbers are multiplied to 7 and add to minus 8. So it's a minus and a plus. So that has to be negative, negative. I go over to my chart here, minus and a plus is negative, negative. And they add to 7 and multiply to 7. So they definitely have to be a 7 and 1 because 7 is a prime number. And then what I do at the end here is I just throw the y's in at the end. Okay, because there were y's initially here. So you have x minus 1y or x minus y and x minus 7y as your two factors. Same with this. I'm going to ignore these y's, just 14x here entirely. And then I'm going to say two numbers that multiply to 49 and add to 14 and plus plus. And what you find here is that 7 and 7. Once you do that, it's 7 and 7. And because there was a y, I'm going to throw the y's in at the end, final answer. Now, what they've done here is they've made this a perfect square. And they said, since these are the same, why don't we write it like this? It's x plus 7y and x plus 7y. What do I write is x plus 7y squared. And you can do that if you want or not. So once you have that, let's go back now to the graphing part here. I'm going to go back up here to graphing. Once you have that, you can get your zeros. So this is a little bit of, so back to factoring here and then graphing. What is it doing? And graphing. Let's see if we can stay here. Can we stay here? Yep. What you do here is, if this is an equation, y equals this, you set it to 0, and then you do the same thing we just did. You factor x plus 3 and x minus 1. So two numbers will multiply to negative 3 and add to plus 2, plus 3 and minus 1. And then if you remember, you set this to 0 because you're asking yourself, when is the line going to be on the x-axis here? And to get your zeros or get your roots or your zeros or your x-intercepts, you say y is equal to 0 because if you think of this, when I'm at 0y, I'm actually on the x-axis. Okay, so I'm going to have 1 or 2 or no zeros, but in this case, you'll have 2 different zeros, and you'll plot the zeros to get to your parabola. So you factor this x plus 3 and x minus 1, and then to get your zeros, you just change the signs. So this is x minus 3, and this is x is 1. Okay, so your zeros are negative 3, 0, and 1, 0. So that guy gets you that one gets you that one, and then to keep graphing, you want to get the vertex. So to get the vertex, you know that the vertex is in between negative 3 and 1. So you get the x value here by getting the average of negative 3 and 1. So get the h value. What you do is you say negative 3 is 1, 0, 1 is the other. In between them is negative 1. So negative 3 plus 1 is negative 2. Divided by 2 is negative 1. It's the average or the middle. So I know that I'm going to be at 1 here. But the question is, where am I as far as going up and down? And to do that, you sub this, sub h, or x equal to negative 1 into the original equation. So all the steps are written here, but I'm subbing x into the equation. I get negative 1 squared plus 2 times negative 1, subtract 3, and then that is negative 4, and my 0 is 1, negative 4. Sorry, not my 0, my vertex. Okay, and then I have this point, I have that point, I have that point, and I just connect those 3 dots with a nice smooth curve. Okay, and one last thing I want to look at is, finally, the last thing is factoring complex trinomials. Where's that? And we're going to use decomposition. This is actually easier, I think, than other stuff. So what you do is complex trinomial. What you're going to do is you multiply these two numbers together. You want two numbers are multiplied to 4 and add to 5. Okay. So here you notice that this is not a 1. It's not x squared. It's something x squared. And what we're going to do is end up here, and to get here, we have to use something called decomposition. And there's other ways to do it also, but I use decomposition. Most people do now. And two numbers that multiply to 4, multiply to 4, yeah. So you go, they multiply to a times c, so that's a and that's c. Okay, so ax squared plus bx plus c, and they add to 5. So they multiply to that, and they add to b, which is 5. And that, in this case, two numbers that multiply to 4 and add to 5, you say 4 and 1. Yep, they add to 5. So we're done. Okay, so the two numbers are 4 and 1. And what you do is you break up this 5x into those two numbers, 4 and 1. So you go 2x squared is not plus 5x anymore. It's plus 4 and plus 1x plus 2. And you do that because it's going to get us where we want to go. Okay, so you break up that into those two numbers, 4 and 1. And then you common factor the first two terms, and then you common factor the second two terms. So you have 2x squared plus 4x. What's the common factor? 2. And you'll also be able to get an x out. Now, you're always going to get an x out when you common factor these two terms. So it's 2x. And when you do that, you're left with x plus 2. Divide 2x squared by 2x, you get x. And then that leaves you 2. And then here, what's the common factor of 1x plus 2? You might say nothing, but there's always something, at least 1. Okay, so we're going to put a 1 here because you can get a 1 out of x plus 2. And when you do that, you're left with x plus 2. And you always have in the brackets here the exact same thing. And what you do is then you just write the 2x and the 1 here because you're common factoring the whole thing now. And then you write this x plus 2 there. And those are your terms. Okay, those are your binomials, 2x plus 1 and x plus 2. Let's try it again here. Two numbers that multiply to 60 and add to 19. You go through it and you find out they're 15 and 4. Okay, so try different combos in 15 and 4, and you break this up into 15 and 4. It won't matter if you write 15 first and 4 first, or 4 first. It doesn't matter. You get the same answer in the long run. Okay, it might not be the same here in steps, but it will be the same thing in the long run. So you common factor this, and you get 5x goes into both these two terms, and you're left with 2x plus 3. You common factor this, and you get 2, and you're left with 2x plus 3. Again, notice 2x plus 3 and 2x plus 3, and that's what goes here, and 5x and 2 go there. Okay, this one, exact same thing. Just ignore the y. I don't like these anyway, but you can ignore the y until the end and throw the y at the end. And then there's just some other examples here. Fully factor. Oh, why do you keep doing that? Let me just see what's going on. The last one's here, fully factor. You just want to always make sure you common factor first. Okay, so here you common factor, you're left with different squares. Here you can common factor. Okay, you don't see this often, but you can common factor, and then you're left with a simple trinomial. Here you can common factor and left with a complex trinomial. Okay, so the first thing you want to do always is common factor. And that leads us to the next page here. Not this one. So let's just practice. And where is it? Okay, right here. Factor summary. So your factor summary, can you common factor? Yes or no? Okay, you always try to. And then you ask yourself this. Are there two terms or three terms? If it's a two-term question, then you look for a difference of squares. Is there a negative between the two terms? If so, then it's probably a difference of squares. Okay, and then you get these. So make sure you common factor first. So this example here, 18x squared minus 50, you common factor, then you keep going. If you common factor and you have three terms, then you either have a simple trinomial where it starts with an x squared, or a complex trinomial that starts with a number that's not x squared. At this point in our course, you're going to be I'm not going to anything that is a complex trinomial will be factorable, same with simple trinomials. Okay, so just in case you're wondering, that is something not factorable, or do you need the quadratic formula? No, not today. Okay, so that's a lot. Okay, a lot of review, and depending on how you were taught in the past, might be quite a bit, especially with all the at-home stuff that we've run into in the last couple of years. But hopefully, we can get all this down because it's kind of important stuff. Okay, third video all done. See you in class. Take care. Bye.